Okay, problem 1. A druggist has one solution that's 25% iodine, another solution that is 65% iodine. How much of each should the druggist use to get 120 milliliters that is 41% iodine? So highlighted the percentages, they all deal with iodine. We have one that's too weak, one that's too strong. We're trying to make something in between, which is possible. We want to start off with these boxes. And above the box, we want to put the percentages of things that are being mixed together. So the things that are being mixed together making the outcome. So we're going to mix the 25% up with the 65% iodine, and our outcome should be a 41% solution. And again, when we're adding things together, too weak and too strong can make something in between. So anything between 25 and 65 is possible if we're mixing 25 and 65. Next thing we focus on is what we know as far as the exact amount of anything. 120 milliliters of 41%, so 120 goes in the 41% box. It says how much of each, so we don't know either one of these two. That implies that if this is X, and these two have to be combined to make 120, then 120 minus X is what's left over. For example, if this is 10, 120 minus 10 is 110, 10 and 110 make 120. So our goal is to create 120 over here. So for the sake of this test, and anytime we're adding too weak and too strong to get a known amount, it's always going to be X and total minus X. And then once we get the boxes set up properly with our organizer, multiply percent times amount equals, or plus percent times amount, that's a binomial, equals percent times amount. So 25x plus 65 parentheses 120 minus x equals 41 times 120. Use calculator as necessary to evaluate stuff. 25x is fine. If I do 65 times 120, my calculator says that equals 7,800. 65 times minus x makes minus 65x. Then 41 times 120, my calculator says is 4,920. So x, x, no x, no x. So I'm going to put the 7,800 over here. 25x minus 65x is negative 40x, and 4920 minus 7,800 comes out to negative 2880. Dividing both sides by negative 40 gets me an answer of 72. Going back to the question, this is how much of each should he use? 72 represents x, which is how much 25% we have. So 72 milliliters of 25% iodine. And if I do 120 minus 72, that represents this. That comes out to 48. So 48 milliliters of 65% iodine. Right, and again, for a problem like that, that's the type of answer I'm looking for. The amount of one, the amount of the other. Make sure you identify not just the amount, but of which one it is. Number 2, same idea. A chemist has one solution that is 15% salt and 85% water. Now there's 3% salt. We're trying to make 11% salt. And what we can see here is there's percent salt, percent water, percent salt, percent salt. The percent water is just extra information that's not helpful. So we're mixing the too strong 15% salt to the too weak 3% salt, trying to create an 11% salt solution. Again, how many milliliters of each? So this works out very much like the last one did. We got a 15% solution being added to a 3% solution to create an 11% solution. And we're trying to make 1,800 milliliters of the 11% solution, so 1,800 goes here. Once again, I know the final amount, I don't know either initial amount. So if this is x, this is 1,800 minus x. So then 15 times x plus 3 times 1,800 minus x equals 11 times 1,800. And percent times amount plus percent times amount equals percent times amount. 15x is fine. 3 times 1,800 is 5,400. 3 times minus x is minus 3x. And 11 times 1,800 is 19,800. verify that on the calculator. And that is correct. So, move the 5400 to the other side. We end up with 15x minus 3x is 12x. 19,800 minus 5,400 is 14,400. Divide both sides by 12, we get 1,200. Once again, 1,200 represents x, which is how much 15% solution I've got. So 1,200 milliliters of 15% salt. And if I do 1,800 minus 1,200, I get 600. So 600 milliliters of 3% salt. Okay, so two problems of that variety. Pretty much the same exact kind of problem, just practice the skill. Again, the one thing people tend to mess up on is they'll write this part wrong. So x is 1, whatever this number is minus x is the other. And again, too strong, too weak, make something in the middle. Get all that set up properly, most people get it right. Number 3, Queen Hatshepsut rode a litter at 4 kilometers per hour for the first part of the journey to the necropolis. She was going to be late, so she changed to a chariot traveling 10 kilometers per hour for the last part of the trip. 62 kilometers to the necropolis, and the trip took 11 hours. How far does she ride in the litter? How far does she ride in the chariot? So she's here, and she rides in the litter for a while at some speed and goes some distance. She's not going fast enough, so she switches to a chariot, and she goes more distance in the chariot. It's going faster. Altogether, she went 62 kilometers. Nothing tells me that DC and DL are the same distance, but I know that they add up to the total distance. So I know the litter distance added to the chariot distance should equal the total distance traveled. Okay, that's priority 1. Identify the relationship in the distances. Then, if we do a rate times distance chart, we got litter, we got chariot. In the litter, she's going at 4 kilometers per hour. In the chariot, she's going 10 kilometers per hour. It says the trip took 11 hours. That means that not this is 11 or this is 11, but together they make 11. And again, the way we do a total time situation, make one of the times t, it doesn't matter which one. The other time is 11 minus t. 11 came from right here. Right? Whatever the total time is, minus the time you've already used is what's left over. If this is 2, 11 minus 2 is 9. 2 and 9 make 11 hours. If this is 1, 11 minus 1 is 10. 1 and 10 make 11 hours. So let one of the times be t. 11 minus that is what's left over. And we get then rate times time equals distance. So 4 times t is 4t for the litter distance. And 10 times 11 minus t is 110 minus 10t for the chariot distance. Litter distance goes there. Chariot distance goes there. They add up to 62. So I do 4t plus 110 minus 10t equals 62. That's the equation structure. That's my unknowns for DL and DC. Substitute those in. I'm ready to go. Move the 110 over to this side to get all the numbers on one side. 4t minus 10t is negative 6t. 62 minus 110 is negative 48. Subtracting there because the signs are different, negative because 10 is bigger. Subtracting because the signs are different, negative because 110 is bigger. Divide both sides by negative 6. We end up with t is equal to 8 hours. The question, and again, all these questions, these problems always boil down to the question being asked. There's 4 things I don't know. I don't know how long she rode in the litter, don't know how long she rode in the chariot, don't know how far she rode the litter, how far she rode the chariot. Those are the 4 things they might ask for. How far did she ride in the litter and how far did she ride in the chariot? They're asking us for the distances of both of these things. That's what they're asking us for. So, the distance in the litter is 4 times 8, which is 32 kilometers. The distance in the chariot, if she went 62, is obviously going to be 30, but if we just verify that, put 8 in for t, 10 times 8 is 80, 110 minus 80 is equal to 30. Make sure you answer the question they're asking me. If you give me t equals 8 hours, you're going to be wrong. Okay? I've said this 100 times already this year. They ask a question, answer the question they're asking on these problems. Number 4, simplification of imaginary number expressions. Keep in mind we have I to the first, I to the second, I to the third, I to the fourth, I1, negatives in the middle. So there's your powers of I pattern. First, second, third, fourth, fifth, sixth, seventh, eighth, and so on. So, and we want to have these outcomes for each of these things. So when I see 4I to the fifth, that means 4 times I to the fifth. First, second, third, fourth, fifth is the same as I to the first. When I see I squared, it's minus, so I put minus, and I squared is equal to negative 1. Again, the minus sign is part of the expression. I squared happens to equal negative 1. When I see 5I cubed, it says plus, so plus 5 times I cubed. I cubed, first, second, third is negative I. It's being multiplied. That's being multiplied. That's being multiplied. Then it says minus the square root of negative 16. The negative sign makes an I, and the square root of 16 is 4. So altogether I'm going to get minus 4I. Notice that this stays negative because of subtraction. The minus in the radical creates the I. Once you make the I, the minus goes away. Square root of 16 is 4. So at this point I'm down to either expressions containing I to the first power or real numbers. Next thing I want to do is simplify each expression completely. So if I start with this one, 4I is just 4I. Can't make it any prettier, I took the parentheses away. Minus 1 is plus 1. Plus 5 times negative I is minus 5I. And minus 4I is minus 4I. So get everything down as simple as possible and then add like terms. Real number goes in front. Imaginary number goes in back. It happens that 4I and minus 4I cancel. So we get negative 5I. Could have also gone 4I minus 5I is negative 1I, minus 4I makes negative 5I. Real number first, imaginary number second. Please get in that order. Number 5, once again, I's to powers. So I have I to the fourth power, I have I to the third power, and I've got a radical. Make that positive, put an I out in front. My rule again, I to the first, I to the second, I to the third, I to the fourth. You're right, I1, negatives in the middle. 5I to the fourth is going to be 5 times 1. I to the fourth equaling 1. Again, that's 5 times that, so 5 times 1. The square root of 25 is 5, being multiplied by I. And then 4I cubed. I cubed is negative 1, negative I. I cubed is being multiplied by 4, so negative I is being multiplied by 4. Once again, get everything as simple as possible. That's positive 5. That's positive 5I. That's positive 4I. Real number, imaginary numbers. 5 is real. 5 plus 4 makes 9, so 9I is the imaginary. That's the answer. Number 6, solve by completing the square. First task is to get the x's together on one side equal to the number. So I'm going to move the 6x over there. So 1 leaves some space equals x squared minus 6x. Step 2, complete the square. We take half of that number and square it. Half of 6 is 3. 3 squared is 9. I add 9 to both sides. Okay, so again, that's the completing the square step. Doesn't matter what the sign is, it's always plus, and it's half of that number squared. Half of 6, 3, 3 squared 9, plus 9 is the magic number. Then I square root this side. It always creates a perfect square. Trinomial when I complete the square, so I get a binomial squared. It's square root, and sine. X minus 3. Over here I just add those together. Once I get the perfect square equal to the number, then plus or minus the square root of 10 is equal to x minus 3. That gets the square out of the problem. Now we're just down to x to the first power. Final step is to move the 3 to the other side. Always put the number in front of the plus or minus. So 3 plus or minus the square root of 10 is equal to x. For that one, I'll make sure that's an even number in front of x, so it'll work out like that. There'll be no fractions involved. Number 7, find the equation line. I went to the effort of putting these dots here so you know exactly what dots you'd want to use, so there'd be no confusion. 1, 2, 1, 2, 3, 4, so this is 2, negative 4. This, of course, is 3, 0. And this is 4, 1, 2, 3, 4, so 4, 4. Take your pick which point you want to use. I'm going to go from this point, call this point A, to this point B. When I find slopes how far it is vertically and then horizontally to get to the other point, I'm going up 4 spaces, I'm going right 1 space. The rise over the run So the slope is equal to 4 over 1. Write 4, not 4 over 1. If slope is not a fraction, let it be a whole number. All right? Once I know what the slope is, then I take one of my 3 points. Doesn't matter which one. I'm going to pick this one. My job is to find the y-intercept. Y equals mx plus b is the exact structure of any linear equation. And m is 4, x is 3, y is 0. So I substitute those 3 numbers in. 0 equals 4 times 3 plus b. The only missing part here is b. If I go ahead and solve this, I get 0 equals 12 plus b. Move the 12 to the other side and subtract, I get negative 12 equals b. Slope of 4, y-intercept of negative 12, answer of y equals 4x minus 12. Again, that's my structure of a correct answer. Replace m and b with the m and b we find to get the correct answer. Number 8, solve. We have a radical expression equal to a non-radical expression. Job 1 is to get the radical expression isolated, which it already is. So job 2 then is to square both sides. Squaring the left side just gets rid of the radical. Squaring the right-hand side gets us a binomial squared. So we get a trinomial. Object 1 is object squared. Object 3 is object squared. So you square both of those things. The middle object is the product doubled. So positive 3x doubled is positive 6x. If you're not comfortable with the shortcut, just do x plus 3 times x plus 3 with a FOIL. First, outer, inner, last, and you get x squared plus 3x plus 3x plus 9. There's your 6x, that's right there. So again, shortcut or FOIL it if you're not comfortable with that. Now what's going to happen on this problem on the test, it's happening on the study guide, it's happened so far in the homework, is there's an x squared on the left, there's an x squared on the right. If I move one of those x squareds over, let's say I move this over here, what ends up happening is those are opposites, they cancel. So the effect of this expression where we have x squared on both sides equals, which is going to happen, is the x squared just go away. What's left is what we need to solve, which is to move the 6x over here, move the 4 over there. 7x minus 6x makes x, 9 minus 4 makes 5. There's my candidate for the right answer. And I say candidate for the right answer because I have to verify if this number actually works in the original problem. So I check my answer. Every x is going to change to a 5. X squared is 25. 7 times 5 is 35. Plus 4 is supposed to equal 5 plus 3. 25 and 35 is 60 plus 4 is 64. Square root of 64 equals 8 is a true statement, which means that's a good answer. I would expect the one on the test to come out where it actually works. So don't count on the empty set being the right answer to that problem. Expect it to be a regular number. It has to be worked out that way. Number 9, same deal. I got a radical, this time this number and that number on different sides. So again, first job, isolate the radicals. So move the 7 over here. 9 equals the square root of x minus 4. I'm going to square both sides. So squared, squared. And that makes 81 over here and makes x minus 4 over here. Be careful that you're squaring. I see a lot of people, if they see a square root, their brain sees a 9, they want to do a 3 here because the square root of 9 equals 3. I'm squaring to get rid of the radical. I have to square 9 times 9 equals 81 to do that, the consequence of the action. So squaring here, squaring there, getting here. Move the 4 to the other side and change the sign. We get 85 is equal to x. Again, this is the candidate for the right answer. Again, don't expect empty set to be the answer to the question on the test. So it probably will work. If we want to verify, we go back to the original problem as is. It says 2 is equal to negative 7 plus the square root of x minus 4. Notice I changed x to 85. 2 equals negative 7 plus the square root of 81. 2 equals negative 7 plus 9, which I can see very clearly is true, which means that's the right answer. Again, if this came out false, then you just empty set it. But I would count on this test having an answer not empty set. Number 10, simplify 5 times the cube root of 5 times the fifth root of 5, where the fifth root of 5 is inside the radical, the cube root of radical. So our first task is to get this expression down to 5 raised to a power. So the 5 out here that's being multiplied by the cube root of the whole thing is not even affected by anything until we deal with the inside object first. This part is just 5 to the first power, that's this part, and this other part here is going to be 5 to the 1/5 power. Alright, so we create fractional powers. We want to write things in power form, so just instead of 5, 5 to the first power. Alright, then 5 stays 5, the cube root stays the cube root. I'm going to multiply these two 5s together here by adding the powers up. If I do 1 plus 1/5, that's 5/5 plus 1/5 is equal to 6/5. Okay, notice 5 and 5 remains 5. I multiply by adding powers. So if I'm going to use a power rule to multiply, the base does not modify. 5 stays 5. Once I get to this point, single object in the radical, now I take the root, the index, times the denominator to get this whole thing fixed. So 5 stays 5, 6 stays 6, 3 times 5 is 15. That's still being multiplied by the 5 that's out here, which happens to be to the first power. Now, this does reduce. It's worth doing. Divides by 3 down to 2/5. All right, if you didn't see that, you'd still get a right answer that's unreduced, but you can make numbers small, it's worth doing. So I'm going to multiply these 5s the same way I multiply these 5s. I'm going to add the powers together. So I'm going to get 5. If I do 1 plus 2/5, that's 5/5 plus 2/5 makes 7/5. So 5 to the 7/5 power is the correct answer. One of the tests is going to be structured just like that. And again, that's the technique you want to use. Create the fractional power, add the powers to get a single, multiply to get out of the radical, add to get a single. And every time, whatever this number is in the answer. At no point do we multiply the 5s any other way than by adding powers. Number 11. Cube root of 27x squared y to the 4th times the square root of 9x to the 5th y. First off, the cube root of 27 equals 3, because it does. Okay, there's no trickery to that. 3 times 3 is 9 times 3 is 27. That's just what the cube root of 27 is. So when you get a number in a problem like this, just take its root. Evaluate it. As far as letters are concerned, I've got x to the 2nd power inside a cube root, so 2/3. I got y to the 4th power inside a cube root, so y to the 4/3. So for the letters I'm going to raise to fractional powers, the number is going to evaluate to a nice pretty number like 3 in this case. On the second radical, I've got 9. This is being multiplied, so times. The square root, which is understood to be here, square root of 9 is equal to 3 because that's what the square root of 9 is. Again, evaluate the numerical values, just get what you get on those. As far as x and y are concerned, this x is to the 5th power. It's being taken to square root, so 5 halves. The y is to the 1st power as a square root, so y to the 1/2 power. So every letter you're going to take the power inside divided by the root outside. If those fractions happen to reduce, you should reduce them, but they don't. What's left to do is to get an answer for this. 3 times 3 makes 9 because that's what 3 times 3 equals. Okay, there's no trickery here, it's just that's what 3 times 3 is. As far as x and y are concerned, I'm going to add powers. For x, I've got 2/3 and 5 halves. I'm going to make a common denominator of 6. So 4 plus 15 over 6. 3 times 2, so 2 times 2. 2 times 3, so 5 times 3. For y, also a common denominator of 6. Times 2 times 2. Times 3 times 3. So my final answer is a number times an x to a power times y to a power. So 9 is the number, x to the 19 over 6, y to the 11 over 6. And that's what your final answer should look like on that one. Again, on the test you're going to have cube root of some number or square root of some number that has a nice pretty cube root or square root. It might be 64 and a 8, whatever. It'll be something that has perfect cube roots and square roots. So make sure that you evaluate those numbers exactly, and then the numbers just multiply to make a new number. Other than that, everything is what it has been in those problems. Number 12, simplify. What I'm looking at is a quadratic over a cubic function. I can see the cubic function has a common denominator, a common factor of x. The quadratic is factorable. Negative 10 is negative 5 times 2. So I would go x minus 5, x plus 2 on top. I can see this is x times x squared minus x minus 20. So x is the common factor taken out. Negative 20 is negative 5 times 4. In each case, the product of negative 10, adding negative 5 and 2 makes the middle coefficient negative 3. The product of negative 20, negative 5 and 4 add to make negative 1, the middle term's coefficient. So everything's factored exactly as it should be. X minus 5 cancels x minus 5. Everything else doesn't cancel. So we're left with x plus 2 on top, x squared plus 4x on the bottom. That is what I'd expect your final answer to look like. Just multiply everything back together after you've taken out common factors. Number 13, simplify. We got a complex fraction. We got fractions inside of fractions. So main fraction bar is here. There's a term, there's a term, there's a term, there's a term. Notice there's minus signs on there, so make sure the minus signs show up in your answer. The common denominator of all the identified fractions, this is not a fraction here, p is just p. I got p cubed, and p squared, so the least common denominator is going to be p to the third power. It's always whatever the common factor is, raised to the highest power that you see. So p is all common, highest power is 3, so p cubed is the magic thing. So I'm going to multiply by p cubed. I'm going to multiply by p cubed. I'm going to multiply by p cubed. And I'm going to multiply by p cubed. There's my fraction bar. I've got a minus sign and a minus sign because that's what's there and there. Too often I see people get everything right except they put pluses because they just want to put pluses and everything. Whatever sign's in the problem, that's what goes there. I get object 1, object 2, object 3, object 4. And we get each object by simplifying. Numerator object cancels by denominator object. We're left with just the numerator, x cubed y. Non-fraction times non-fraction just makes a bigger non-fraction. 3 plus 1 makes 4. Numerator divides by denominator, leaves me with a p. Oops, that's supposed to be green. P squared goes into p cubed p times m is mp. And p cubed cancels p cubed, leaving us with just minus 3. Simple fraction, simple numerator over simple denominator. Answer's done. Number 14, find the equation of the line. Find the slope, find the y-intercept. Passes through the point 5, negative 3 is parallel to the line 2x minus 5, y equals 5. Parallel lines have equal slopes, so I'm going to use the equation they gave me, 2x minus 5, y equals 5, to find the slope. So if 2x minus 5y equals 5, that means negative 5y equals negative 2x plus 5, if I move the 2x over there. Divide everything by negative 5. And I get positive y is equal to positive 2/5 x minus 1. The slope is the number in front of x, so 2/5 is the slope of this line. So it's parallel, which means the slopes are equal, so the slope of the line I care about is also 2/5. So I go over here. I know my slope is equal to 2/5. It passes through the point 5, negative 3, and again I'm at the same place I was earlier in the test. Y equals mx plus b is my structure. M equals 2/5. X equals 5. Y equals negative 3. I simply replace those three values with the three numbers. So negative 3 for y equals m 2/5 times x 5 plus b. It just so happens that 5 and 2/5, the 5's cancel. That doesn't have to happen. If this ends up being a non-fraction though, write it as a non-fraction. Don't give me 10 over 5. Don't give me 2 over 1. Just write it as 2. It canceled. It makes a nice pretty whole number. Let it be a whole number. Alright, move the 2 to the other side and we get negative 5 equals b. Slope is 2/5. Y-intercept is negative 5. M and b get replaced in that structure. So y equals 2/5 x minus 5. And the final problem. Solve. This is a problem that in years past people miss a lot because of this minus sign. It might also be it's the very last problem on a test that's already taxed your brain a little bit and you're not thinking straight at this point. That minus sign is subtracting that second fraction completely. If I were to separate these fractions out, so this right here is fraction 1, This right here is fraction 2. I'll show you exactly where people mess up, and hopefully that you won't do the same thing. 2x plus 5 over 3 makes 2x over 3 plus 5 over 3. You just split apart the numerator objects over the denominator. The second one is going to become minus 3x over 6 plus 5 over 6. The place people mess up is right there. Okay? This minus sign is not only hitting the 3x, it's also hitting the minus 5. So the minus minus makes a plus. You may notice that 3 6 reduces to half. Go ahead and do it if you feel like it. It's not really going to help. Equals 7. The reason it's not going to help is I still have a 6. So the least common denominator is 6 no matter what I do. I'd probably just leave it as 3 6. But again, split the binomial numerators apart. So object 1 over bottom, object 2 over bottom. Just make sure that minus sign attaches to that minus sign to make that a plus sign. That's where people are going to mess up. From this point forward, it's a pretty basic problem for everybody. I'm going to multiply by the common denominator of 6 to get rid of the fractions because we don't like fractions. We divide, then multiply, so 6 divided by 3 is 2, times 2x is 4x. 6 divided by 3 is 2, times 5 is 10. 6 divided by 6 is 1, times negative 3x is negative 3x. 6 divided by 6 is 1, times 5 is plus 5. 6 times 7 is 42. That's not a fraction, so just multiply straight. Just like that, we get a non-fraction problem. 10 and 5 make a total of positive 15, which will move to the other side. 4x minus 3x is equal to x. 42 minus 15 is equal to 27. Subtraction because the signs are different, positive because 42 is bigger. Subtraction because the signs are different, positive because 4 is bigger. No division necessary since x equals, so that's the answer. Right there, be careful. That sign changes because of that minus sign. There will be a minus sign on the test in that same place.